Here we have an example on the continuity equation to know how to use it in solving problems. So the example says that the average velocity of blood in aorta that extends from the heart and the radius of aorta is 0.7 centimeters. So the velocity of blood in aorta is 0.33 meters per second. And then this aorta extends into 30 main arteries. Accordingly, it supplies them with blood. And the radius of each artery of these 30 main arteries is 0.35 centimeters. So it's half the radius of the aorta. Then we need to calculate the velocity of blood in each artery. The velocity of blood in each artery. Okay. Now, here we have 30 main arteries extending out of aorta. We know that the continuity equation is A1 multiplied by V2 multiplied by V1, equals A2 multiplied by V2, where A is the cross-sectional area at the first, or the first part of the tube, and velocity is the velocity of liquid in the first part of the tube. Then A2 is the cross-sectional area of the second part of the tube, and V2 is the velocity of the liquid at the second part of the tube. But here we don't have two tubes. We have aorta here at that side, and here we have 30 arteries at that point. No problem. We will deal with the 30 main arteries as if they were one artery by getting the cross-sectional area of one of them, then multiplying it by 30. Then multiplying it by 30. So here is what we are going to do. So first of all, the A1 is the cross-sectional area of aorta, and as if it's, because it's circular, so the cross-sectional area will equal pi multiplied by R1 squared, and then we have V1 equals 30, and then we open a bracket, then we have pi R2 squared multiplied by V2. Simply, V2 will equal pi R1 squared multiplied by V1 over 30 multiplied by pi, then R2 squared multiplied by V2. No, here's the V2. So we can neglect the pi's, and accordingly, here the result will be 0.007 squared, because this is in centimeters, and according to plug it in inside the equation, we have to change the unit into meters. So 0.7 over 100 gives us a 0.007. That multiplied by the velocity, which is 0.33, and then we have 30 multiplied by 0.0035 squared. This would give us a velocity which equals 0.044 meters per second. So this is the velocity in each one of the main arteries, and we can notice that it's much lower than the velocity of blood in the main aorta, in order to give time for the blood to diffuse and exchange constituents like oxygen and nutritive materials and stuff like that. So that was an example on the continuity equation. Until the next time, we are going to talk about viscosity in the next time, and until then, I thank you for watching, and see you.